Hi everyone, and welcome to today's video on single replacement reactions. What single replacement reactions are is we have a free element that's going to react with a compound. And what they will form is another compound and another free element. And so something is going to switch places. We have a reaction format, and the way that we write that is A plus BC is going to form B plus AC, where A is an element, BC is a compound, and it looks like A and B are switching places because on the product side, B is now by itself. B is the free element, and A is joined in the compound. So a single replacement reaction is typically going to look like this. And in a single replacement reaction, to know whether one metal is going to replace another metal is determined by the relative reactivity of the metals. We have what is called an activity series that arranges the metals in order of decreasing reactivity. It's already determined in a list for us, so we just have to know how to use it. What you need to know is a reactive metal. So typically, this is your free element. So the free element will replace any metal listed below it in the activity series. And this metal is from your compound. Okay? So the reactive metal, which will be your free element, will replace any metal in a compound below it in the activity series. So let's do a few examples. Here's my activity series, and what you need to write down is that your most reactive elements are on the top and your least reactive elements are on the bottom. Okay? So here's my first example. Magnesium looks like it's going to react with zinc nitrate, and I don't know what my products are going to be. So I need to first figure out if a reaction is going to happen. I'm going to put my letters from my reaction format into this example so I can kind of figure out what's going to switch places. Magnesium is the free element, so I'm going to label that A. Zinc nitrate is my compound BC. Zinc is the metal, so that gets the B, and nitrate is the C. From the format above, it looks like A and B are going to switch places. So what I want to know is magnesium going to replace zinc? So I need to find where my free element is first on the activity series. Magnesium is here, and I'll label that as an A. Zinc is here, and that's a B. So if A is above B, then a reaction will happen. So my products are going to be B and AC. Zinc is going to now be the element by itself. So I'm just going to write zinc as a free metal. That's going to be a solid. Okay, now A and C are going to be my compound. A was magnesium and C was nitrate. But now I can't really just switch places with my ions. I have to think about what that compound is going to look like. So I need to know the charges on those once again. Magnesium is a +2 and nitrate is a -1. So the formula for my compound AC is going to be magnesium nitrate, parentheses 2 on the outside. So why does magnesium replace zinc in this example? Magnesium is above zinc in the activity series. Okay? And of course I need to make sure that my equation is balanced. This here is aqueous. It looks like everything is balanced, so I'm good to go. Okay, let's do a second example. Copper plus silver nitrate. So copper is my A, that's my free element by itself. And then silver nitrate. Silver is the B, and nitrate is the C. I want to figure out if copper is reactive enough to kick out silver. So copper, I'm going to find copper on the activity series. Copper is an A. Silver is the B, and silver is below it. So if A is above B, then a reaction will happen. So again, my products are going to be B plus AC. B is now going to be silver by itself. Silver is going to get kicked out of its compound, and so we'll label that as a solid, plus my compound AC. Okay, so now I have to think about what charges copper and nitrate are going to have. Copper, in this case, is going to be a +2. And nitrate will be a -1. Copper is a transition metal, and it can be a +1 or a +2. I'm picking the +2 charge because that's the more common charge. So +2 and -1 means my formula for my compound is going to be copper nitrate. And I'll put a 2. Whoops, that 2 doesn't go there. 2 goes in front of the silver. Okay? So again, this reaction happened because copper is above silver on the activity series. All right, and let's do a third example here together. Sodium and lithium nitrate. It tells me there's no reaction here. Let's figure out why. So sodium is my A, and lithium nitrate is my compound. So let's find where sodium is on the activity series. Sodium is here, and lithium is here. So this is a case where A is not above B. A is below B on this example, which means sodium is not reactive enough to replace lithium. So there's no reaction. There's no products that I can make for this reaction. And the reason for that, again, was because sodium is below lithium on the activity series. Okay, and let's do one final example here. I have aluminum reacting with calcium sulfate. So aluminum is my element, calcium sulfate is my compound. Aluminum, let's find where that is. Aluminum is here. Label that as an A. Calcium is right here. And once again, I see that aluminum is below where calcium is. So aluminum is not reactive enough to replace something above it. So there is no reaction. And I just don't write products for that. This is what my reaction looks like. Nothing happens in real life. So again, the reason for that is because Al is below calcium on the activity series. Okay? And you can go ahead and try these two examples on your own using the activity series above you. We'll go on to the second page and do a couple more examples, because I can also use an activity series with nonmetals, and it works exactly the same way. My most reactive nonmetals are on the top, and my least reactive nonmetals are on the bottom. Okay, and there's only 4 to choose from. I'm really just only concerned with the halogens for these reactions. So again, a reactive nonmetal, let's say element, like this is your free element, will replace any nonmetal in a compound listed below it. Okay, you might want to add in these descriptions just to really be clear which one you're trying to figure out if it's going to replace. So the reactive nonmetal element will replace any nonmetal that's in a compound below it in the activity series. My reaction format looks a little bit different for this one. I'm going to have D plus BC. But now D and C are my nonmetals. And so the way that I write my compound needs to reflect that. So C is going to be the element by itself now, and B and D are going to be the compound. So D and C are going to switch places because they're nonmetals. Okay? Let's do a couple examples. So I have chlorine and sodium bromide. Chlorine is my free element. Sodium bromide, this is my BC compound. And so I want to know if the free element is going to be above what it's going to replace in the compound. So D is right here. D is chlorine. And it's going to replace bromine, which is the nonmetal. So D is above C, which is what I want here. The reactive nonmetal, which is D, will replace elements below it. So C is below D, so a reaction will happen. So I will write C plus BD and then make the formulas for my products. So C is going to be bromine by itself now. And I have to remember my Brinkelhoff elements here. My Brinkelhoff elements are all nonmetals and they're all diatomic, so bromine gets a little 2 next to it. B and D are going to be my compound. So now I have to think about the charges of each of those ions. B was sodium. Sodium is a +1. D is now going to be chloride, and chloride we know is a -1. So BD is going to be NaCl. And I can balance that reaction by putting a 2 in front. So why does chlorine replace bromine? Chlorine is above bromine in the activity series. Okay, and let's do one final example here. Iodine reacting with potassium fluoride. So D plus BC. Iodine is here. Fluorine is here at the very top. So I can see right away that iodine is the least reactive element, and it will not replace anything above it. So D is not going to replace C, which means there is no reaction. I do not write products for this reaction. Okay, there's no reaction because iodine is below fluorine in the activity series. Okay, so go back and review these examples as many times as you need to. Try the rest of these examples on your own. Here are some tips for writing the products. You need to use the activity series. You need to figure out if a free element is going to replace the element in the compound. If it doesn't, then there's just no reaction, and you don't write products for that reaction. If a reaction does occur, I need to switch the appropriate ions, cations with cations and anions with anions. Okay? Try a few on your own. I want you guys to write a summary of what you learned from this video and write down any other questions that you have after watching this video. And we will see you back in class tomorrow. Okay, bye guys.